Hey everyone, welcome to the Elastic LA virtual meetup. Part of the presentation I'd like to have also is, since we are virtual and no one really has opportunity to speak to each other directly, I like to do a speaker spotlight where it gives opportunity to kind of Kit to share what he's done with Elasticsearch, kind of a little more of an interview, 5 to 10 minutes, just kind of so you guys understand what his background is and so on, and when it comes to Elasticstat. So let's start, Kit. So what was your first project with Elasticstat?
My first project with the Elasticstat was probably centralized logging back in 2004 or 2014, excuse me, when the Elasticstat wasn't really a stack yet. You had Elasticsearch, Logstash, Kibana. They were three independent projects, and when I started using it, they had started to merge together as a single project.
Actually, that's the exact time I got involved. Elasticsearch was version 1. I don't know what version, if you remember that, but I heard that going from .9 to 1 was a challenge, but I didn't have to do that. But I ran so I started off with I think Logstash 1.4, Kibana 3, and Elasticsearch 1 something. But yeah, definitely the early days.
I think 1.3 or 1.2 was my first version.
Yeah, that's cool. And then what else? What was your next? Well, how big was that project? And was it with the same company you're with now, or a different company, or?
That was 2 or 3 companies ago. I don't remember. But that was the first one. Then for the same company was doing a proposal capture where they ingested Twitter feed,
Okay.
the 1% Twitter feed into Elasticsearch and used that as part of the proposal capture. I can't really talk about it.
Okay.
The proposal was one. I'll just say that much.
Okay.
And then, switched companies to a new company. Did application search with Elasticsearch and set up, helped move from a traditional SQL database for something that they were doing to Elasticsearch, and using Elasticsearch as the faceted search for the tool that they were building.
Okay. Wow, you got some really nice background. And how'd you get into Geo? What was that?
Geo actually has been all on the side. I haven't done Geo for anybody.
Okay, cool. That's good to know. It's a great side project.
Geo is just something that it's there. I'm kind of curious as to what Geo is.
Okay. What's your favorite parts of Elasticsearch? Well, now it's been 7 years. I mean, how much have you enjoyed the evolution of the stack? It's been crazy. That's what I think. It's unbelievable.
It has been crazy. I think there are some things that I absolutely agree with that they have done. There have been some absolutely disagree but I think that's true of any open source product and any product in general. I mean, you probably could find somebody who was a Microsoft Windows IT administrator who'd administrated computers from 3.1 to 10, and they'd say, these are the things that they should have done differently.
Yeah.
So.
Yeah, I've liked the evolution. I think as it's grown, I know there's definitely the open source side of things and where that is, but it's funny because I went to the very first Elastic conference in 2015, and I always felt like I was like, out of all the people there, felt like maybe 5 to 10% were DevOps people. Everyone else was more just straight Elasticsearch was like the big one, and I've always done analytics with it, so that's been very interesting. Like as it's grown, I think that the base has really changed and really evolved, which has been interesting. adding security, and I always did analytics with it. That was like when I did my log aggregations, we actually threw metrics into the same log/log index, and just created our combined dashboards off of that. So always been like that for me. But I do think there's between search and then the security and then also observability, as it kind of starts splitting these out into three kind of more product lines overall. It's interesting there. But yeah, I'll dive into the open source part. I know Shai gave a good explanation of his failings at the community conference, so we kind of leave it at that.
Yeah, I'd completely forgotten about that. I wasn't even talking about that.
Okay.
that was not even a train of thought. It was, some of the deprecation that they've done with Logstash and moving forward with beats and then deprecating beats, and that's more what was my thought.
Okay. Yeah, Logstash has been interesting. It's been my favorite tool. So actually, I did a Logstash first. Logstash actually, its preferred backend was Mongo when I first started looking at it before production, but I was just kind of following it through. And so that's why, I needed a login solution besides Splunk, because I could never afford Splunk anymore, and that was my challenge. And that's how I got into it. And that's fallen to probably 2012. I did some, but it still wasn't ready yet. 2014 was really when it started coming together. You could see the momentum though, which is really interesting from the DevOps side of things. But just made, when you can visualize your logs, it's so powerful to troubleshoot and so on, and then work with other teams. So that was my best tool for talking to development teams. Hey, we just deployed. Something's going on here. Look at this chart. It's going crazy. Yeah. It just made those conversations so much easier, and presenting what was going on in your infrastructure. But let's dive into your. All right. Before we start, though, does anyone want to ask a question? Try to earn some swag before we jump into his presentation.
I think all of my geo questions are going to be. I'll wait for the presentation to end before I bombard all the geo questions, because that's been something I've really taken an interest in, and I want to do more work around.
Yeah. I think, when I reached out to Kit, I'm like, hey, do you want to present? Because I saw your lightning talk on geo, and I do think geo is harder than it needs to be, at least in my opinion. Like getting into Kibana and so on, and maybe you can show some deeper dive into this piece. But I think it's a little harder than it is. I think so. That was kind of my piece. Is like, it'll be interesting to see how you cover stuff, and I have my questions also ready for you as you go through. So
I'm just going to take what I did for my lightning talk and go a little deeper into it.
Yeah, definitely. All right, I'm going to stop sharing, and let's see. All right. So Kit's going to go a little different. He's doing a little above and beyond. He said that he's not going to actually do a screen share, but he's going to go through. So let's see how this is going to go.
This may work or may not work. If it doesn't work, well, we'll see.
All right.
But before we begin, and going into any demo, I always want to bring up the Summers postulate of software stability. The stability of software is inversely proportional to the size and importance of the audience. And I have found that to be absolutely true. So if things break, I apologize. This is a live demo. So why do I use Elasticsearch as a geodatabase? For starters, it's what I know. It has the ability to store and search either data in point-based data or geoshaped data. I recently discovered that geoshaped data can be joined with point data, although I haven't dived enough into that to be able to say, yes, I fully understand how that works. I haven't found out yet if it can do some of the more advanced geospatial analysis that Esri can, but for most of the amateur and simple GIS work that I've done so far, ES has worked rather well for that. And oftentimes, for what I do with Geo, it's simpler for me to do a script to index the data into Elasticsearch and display it via Kibana than it would be to try and find a GIS tool and put it into that tool. And then ingesting the Geonames database into Elasticsearch. First off, I want to say that since giving the talk at the Elastic Community Conference, others have made me aware of several other options besides the Geo database. I am not presenting a screen, Jay. It's just going to be my video. Are you able to see my video? Yes. Okay. Have made me aware of several other geolocated data sets that include GeoJSON data in a shape format that would allow you to search via oceans, countries, etc. And I have not had the time to update anything to be able to take advantage of those data sets. So let's start by talking about the Geonames database. Oh boy. Transition. All right. So geonames.org is a website that is developed that they take data from all kinds of sources, including USGS. They have a list right here of everywhere that they pull the information from, CIA World Factbook, etc. It's a data set of about 14 million data points, and each of those data points is a building or a central spot for a city, a state, etc. They also have a download for their data that they have that they provide a nice README that gives information about what each of these zip files have. They have one zip file that contains all the countries, all the data that's available. And they have one main table that they use for most of the information. And then several ancillary tables that give additional information that say what the admin 1 code is. So for the United States, that's US is admin 1 code, but that doesn't necessarily, it's descriptive for the United States, but for China, it's CN, which when I first looked at this, I thought that was Canada. We also have admin code 2, which breaks down into a state level. So going on the United States, now you have the state for Colorado, for instance, or California and Kansas, etc. And these are found in a different table. And if we go to that table, all right. This is the that's the All right, so here's the country code, or the admin region 2, I believe, or yeah. All right, this is admin 1. So the admin 1 gives the country, and then admin 2 gives the county. Okay, so admin 1 is the state, admin 2 is the county. So this gives what country
Can you
it is.
can you increase your font or
Sure.
make it larger? It's just a little bit too small. There you go. That's
There we
better.
go. I was trying to avoid that by sharing my screen in its entirety, but for whatever reason, it didn't quite work as I hoped. So anyway, it's broken down with the country code and then the admin 1 code. And then it gives, if memory serves correctly, this is the name for the admin 1, and then I don't remember what that one was, if that was an alternate name, and then the Geoname Database ID. So then if we go into the admin 2 table, it's the same idea, in that we have the country code, then we have an admin 1 and then an admin 2, and that gives the same tidbit of information in that it's now down to, for the United States, it's down to the county level. So to put all this together, I created a custom script. Let me make sure that I'm looking at the right one here. In Ruby to create this whole process. So first step, grab all of the, download the countries and unzip it. Then, go ahead and start processing it. I've got a custom class that I'll walk through. Then create a queue, because we have multi-threaded computers these days. Might as well take advantage of being able to have all the processors working on the one computer simultaneously. And create 2 threads to write out to Elasticsearch, which, yes, this is a snippet to write out to Elasticsearch. It's pretty cut and dry. Create a list of objects and put it into Elasticsearch in one bulk operation. And then for each row in the all countries data file, just start processing one line at a time. So how do we process that? Well, when we say go ahead and create a new one, we initialize it. So go ahead and download the feature codes. So whether it's a city, a state, a county, etc., or a ditch, or a hill, or a street, or a building, download the country list. So translating US into United States, CN into China, AU to Australia, GB to Great Britain. The admin 1 list, that's the state level. So CO is Colorado, FL is Florida, CA is California. The admin 2 list, which is, I'd have to look at it, but it's the same process. Then this just downloads that, creates a hash table locally on the machine to look that up. Same is true with the country list and the admin1 and admin2 list. And then finally, when we start parsing, we take each line and split it and join it with, split the line and join it with the headers. And then do some additional processing for that. Each line, look up a feature class and join those together. And then look up a region name. So admin1, which I rename region name just because it's easier to remember. And then same is true with admin2. And it's just a lookup, country name. And then I also do a copy on the name so that I have two different names. And then I store a copy of the ASCII name. So in this data set, there are two different names. There's the name that is UTF-8, and then there's an ASCII name. So the UTF-8 will also include Cyrillic and accented characters, whereas the ASCII name will just be the basic Latin 26 characters. And then it wouldn't be complete without loading in a template first. And I actually, when I first ran this, I had Elasticsearch generate the initial template. And it does a fantastic job in generating the initial template. However, it always takes some tweaking afterwards. So of course, tweaked it. Something that was a gotcha that I didn't expect when I first set this up was I set the name and it's still set here. It's something that I found this morning, that the name is a keyword rather than a text field. So that means that Elasticsearch, if you search for Los Angeles, or just if you search for Angeles, it won't bring up Los Angeles. But that's the purpose of the parsed name field. So it does catch that when you do a search. So after that's loaded into Elasticsearch, we can then bring up Cabana, and we can do searches on things. So we can say, can do a search for Angeles, goes out to Elasticsearch, and it comes back with 15,000 hits. Any questions so far?
No, I think it's this. If you can just increase your fonts because it's still a little small. But yeah, this makes sense so far. Is there a repo where you have your code, your Ruby, or you're sharing that open source?
I don't have a repo that any of this exists. It exists locally.
Okay.
The one question that I had was, how long did it take to upload all this data? Like, I mean, and how often do you update it?
So right now I've just been updating it for the talks. So let's see here. To do the last load for this talk in particular to my 9 node cluster running in AWS right now, it took about 30 minutes. If I was doing this, constantly to have as something that I was updating more frequently, I probably would update it about once a month.
Have you noticed when you've done those changes, the data probably doesn't change that often, though, right?
I don't think it does.
No.
I haven't done any checks. I know that when I first loaded this, it was about 11,500,000 data points, and it's now over 12 million.
Yeah.
And this is just so I'm making sure I'm understanding right. This is just city, county, important landmark type data. It's not necessarily like down to the street address level.
It's not street address level, no. But
I
like,
it seemed light.
let's see here. We can do a search for Everest, and it should, yeah, here, Mount Everest. My laptop wouldn't lock up. And I'm sure that if you punched in the coordinates to Google, it would come up with the summit of Mount Everest. So, and Geonames does have a data set that does include street address, but it's only for the US. It's my understanding anyway. All right. So let's see here. All right. So I guess the next step I took was I had ingested into Elasticsearch the earthquake data set from the USGS. And when I did that, let's see here. So it created a fairly let's see here. $100 years ago to relative 20 years ago. Okay.
You have Everest still in your search.
Oh, yeah. I can tell I don't use Discover all that much. It does create a useful data set. As much as I want to keep this going, this is not working. All right, it does create a useful data set, but it's not, if trying to do something beyond just put the points on a map, there's nothing really there to be able to say, okay, the United States had so many earthquakes, China had so many earthquakes, etc. So that is available from the USGS. I'm not saying that it's not available, but it's something that for every one of these earthquakes, you would have to do a query for in the bulk and then do a query for each of the earthquakes. So whereas this data set of 1.5 million takes about half an hour to ingest into Elasticsearch, you'd be making 1.5 million requests to the USGS, and they probably would kick you off for spamming their REST API. And it does include some location information in the earthquake itself, but it's not a standard. This is what this is, Yellowstone National Park, Wyoming, US. It is not the standard, because some of them will be 10 miles northwest of Los Angeles or 25 miles southeast of Timbuktu. So it's not standard enough that I could run a pipeline to be able to process and tease that information out. So in adding the additional information, let's add the index pattern. Come on. Start next step. We can then come into visualize. And we can come into our visualize and we can split rows, and we can say, all right, we want terms, and let's base it on country. Say update, brings up the top 5. Most of the earthquakes that were recorded were in the United States. So how did I get there with the pipeline is probably the next question I should answer before I continue. So let's see here. I need to switch. New share. Okay, so I wrote another little processor. Originally, this was one big, long Ruby script to do all the processing all at once. But when I moved from having it local on one machine being fed into 3 or 4 different machines, into the cloud, I moved it to having RabbitMQ in the middle. And with that, same approach. I want this to be multi-threaded. So let's start with just what years are we going to ingest? So I create an initial list, a seed list of 1900 to 2020. And with that, now I have every year in the last 120 years that the USGS has data. And I have put in earlier, 1880, and there's nothing before 1900 in their repository that I've been using. And then they have a limit of 20,000 earthquakes per request in their bulk API. So the first thing that I do is I say, okay, go ahead and get the count for each one of those years from the USGS. How many earthquakes are we talking about? Are we talking, there was 1 year of 1,000, or was it 1 year of 500,000? And when I get the counts, if it's more than 20,000, and if it's more than a year, I break it into 12 months. If it's just a month, if we've already broken it into months and this particular month that we got the counts for is more than 20,000, it breaks it into days. I haven't found a day that had more than 20,000 earthquakes. So that's pretty safe to assume that works. And then it puts the good dates into, and if it's less than 20,000, it says, okay, this is a good date to go ahead and send a query to the USGS and get the information out. And then I have a sleep to stop between the two sets of threads. And then I start getting from those good dates, I start getting earthquakes from the USGS and put it into Elasticsearch. And so go ahead and check to see how many, if is there anything left, and then process the features and get the, just, that's a helper function to just get everything from the USGS, and then processing the features is pretty much just go out, grab it. There's a few things that I change, in the data set that comes down. They have mag instead of magnitude. So I changed the name on that. They also have a couple of different types that they'll have in there. So go ahead and split that apart. Change their dates so that it meets a little bit more Elasticsearch like JSON, and then continue on, take the two dates, then create a location, set a depth, and then delete the fields that aren't used. And then from there, push out to RabbitMQ. One path does the unenrichment, and then the other path does the enrichment. So if we come to our enriched side of things, just have a rabbit, a bunny consumer, create the bunny consumer, and just while there's data in the Elasticsearch or into the RabbitMQ queue, just go ahead and grab data. and then go ahead and query Elasticsearch directly. And then if there's something, go ahead and pull it back and include it inside of the GeoData set and append it, and then pass it back to RabbitMQ. And then finally, just create 2 threads, one to write the enriched path and one to write the unenriched path to Elasticsearch. And as far as a template for each of the earthquake data sets, they both use the same template just because it's easier to keep track of. And the unenriched data set will have all the same fields that the enriched data set has. The enriched just has more of them. And I think that's all that I have.
All right, everyone. Thanks for joining. Kit, thanks for the demo and kind of going through how you're pulling the 2 sets of data in.
Sounds good.
Thanks, everyone.